talk about what a wave is and types of waves. Waves are disturbances that carry energy through matter or space. Most waves are going to travel through some kind of medium. A medium just basically is the route in which the waves travel. For example, you have water is the medium in ocean waves. The wave goes forward and the water is what it goes through. In seismic waves, earth is the medium. It's the place in which the waves go through. And when you have sound waves, the atmosphere, the air, is the medium. And all of these waves that require a medium are called mechanical waves. Mechanical waves require some kind of medium, like the air, the water, the earth, to go through. Now there is one kind of wave that does not require a medium. You probably guessed what it was since it's right here. Electromagnetic wave does not require a medium. So what is an electromagnetic wave? Magnetic wave? Well, light. Well, you probably noticed that the sun, and I don't have a picture of the sun up here, but light from the sun gets to the earth. But it has to go through this space that doesn't have any atmosphere in which to do it. So that light can indeed travel through things that are not air or not water or not some kind of medium. It goes through the empty space, I guess might be a good way to put it. Something here on Earth does that too. Another electromagnetic wave is radio waves. Waves from hearing the radio is an electromagnetic wave. Does not need a medium, even though it happens to travel through the air. Also, it could bounce off satellites, which are out there with no air. So, whenever you have an electromagnetic wave, oftentimes people refer to them as light waves, even though they could technically include the radio waves as well. So, do waves do work? Well, energy is defined as the ability to do work. And waves, of course, can create energy. If you have waves here on this pond, it is going to move the bobber up and down and move the bobber a little bit another way. So that's actually doing some kind of work there. So yes, waves can do work, and yes, they create energy. Waves spread out from their source. So if you have a speaker, the waves, of course, will be spreading out from the speaker in opposite directions. And it's kind of like a puddle. Like if you were to drop this bobber in the water, it would send ripples in circular or in spherical waves, and that's often how you find these types of waves. Motion in our throats creates the waves coming from our voice. So this dude singing in the shower right here with his sponge, the sponge is not a medium, but he, in his throat, and everybody's throat who can speak, have a apparatus, the voice box, which can create motion. And that's what starts the waves, and our tongue and our mouth opening up and down. We've learned how to control that to where we can say what we want to, and then the waves come out from there in whatever distance, depending on how loudly this guy is singing. I hope it's not too loud. He does not look like a pro. So, looking at my notes here, trying to see where I got to, I kind of lost my spot. Scientists even think that these electromagnetic waves starts with some kind of motion. All these mechanical waves, you know, will, like somebody singing, like somebody moving this rope up and down, like waves taking this bobber up and down. They're all some kind of motion. And scientists even think that the ions, you may remember that ions tend to have a molecular movement to them. So if scientists think that the ions and that electrical movement is kind of what starts these vibrations, and even the electromagnetic waves. Let's take a spring right here. I'm going to change colors. Let's take a spring right here. It has some coils that kind of act like waves do. If you pull the spring down, it has potential energy. The potential of you letting it go and it going back up and doing work. Movement up, movement back down. If you release it, of course, you have kinetic energy. So waves have both potential energy and kinetic energy also. And they can be transferred, kind of like a series of these. If you pulled this one down and it went up, the vibrations from the board it's on could end up sending another one down. Kind of a transfer of energy, you might say. Waves can do that. And you don't have to know this, but that's called harmonic motion whenever you have waves being transferred over and over and over. But most of the time we have damped harmonic motion because simple harmonic motion doesn't ever stop, and we have friction here on Earth, which means that harmonic motion would eventually die down. This transfer of energy and wave in motion is seen in moving a rope that is fixed at one end, and you can see this dude right here who is doing exactly that, who is moving the rope up and down. Now this is a lot like how some of the waves happen to be. As the energy in the rope passes, the actual motion is up and down. Now here's what I mean. Let's say you have a red ribbon that is tied right here on this rope. As this guy is frantically going up and down, that's exactly what the red ribbon will do. It will go up and down. So the actual movement that you have is up and down, but that's not the direction that the wave is going. The wave is going this way. The very first time he shook this, he went up, the ribbon went up, he went down, the ribbon went down, and this rope, the energy just kept going up all the way through here. So whenever you have waves that are like that, where you have the motion is perpendicular to the direction. Remember, perpendicular is not parallel. Motion and direction are in opposite ways. That would be called a transverse wave. Now, not all waves are transverse waves, but some of the more common waves are. Light waves, for example, are transverse. Light waves kind of have a look like this. Anything that would, the movement is up and down, yet the waves keep going forward. It pushes the energy, this up and down movement of all the atoms, of all the molecules of the air here, will push the energy forward. So I mentioned that light waves are transverse. Now imagine another kind of wave, this slinky in the hand. In this slinky in the hand, let's say you had a red ribbon, if you could do this. Let's say you had a red ribbon tied to the slinky, and the slinky is all up here in your hand. Once you let it go, the red ribbon is going to go down. And the direction is also going down. So you can kind of see where I'm going at here. The transverse waves are opposite, where you have the up and down of the motion, but the direction is perpendicular to it. Whenever you have the direction and the motion going in the same way or parallel, then it would be a longitudinal wave. We have some things that are longitudinal waves. Motion is in the same direction as the waves. Sound waves are longitudinal. Now there is one other term we need to talk about. That would be surface waves, and that's why I have this little diagram right here. Now this is a very flat surface here for this bobber, but imagine that the bobber had wind around it. Now, you know what's probably going to happen, but let me point out what you have here. You have two different mediums. You have the water and you have the air. So surface waves are going to happen whenever you are at the boundary of two different mediums, because things can happen a little differently there because you have the two different mediums. If you did indeed have waves coming here, you would have two things that would happen. The bobber would not go straight this way, but the bobber also would not go up and down and stop. It's going to be a combination. If you have 3 minutes, say, of windy weather, you're going to have a lot of up and down motion, but the bobber will probably gradually move to this direction of the wind. So you do have both perpendicular and parallel motion here, and it's because you have two different mediums here. So those are surface waves, ones that are at two different mediums. This wind up here, it's blowing this way, and there's really not an up and down to it. It is blowing that way. But if you were to have, say, a tsunami in the ocean, it is going this way also, but it's kind of going in, it's kind of just going underneath the surface until it gets really close to the shore. So even though you have those directions right here, you kind of have an up and down, and you kind of have it pushing to the direction of the wind. So you do call that surface waves.